Welcome to Civil Mech Maths Concepts by IITian. From this channel, as a part of my lectures on MCQs for SSC JE and GATE in fluid mechanics and hydraulics. Fluid mechanics and hydraulics. This is the second lecture. In the first lecture, I have given some MCQs with the background explanation, and in this, I will be giving some more MCQs with sufficient amount of subject knowledge behind them. Let's go into the MCQs. Let us make MCQs to look bigger. These are made by me, and first MCQ is, for knowing the properties of fluid. Properties is come two times. For knowing the properties of fluid, the space and time are required. Space details and time details are required. The space and time respectively are unidimensional and three-dimensional, three-dimensional and two-dimensional, two-dimensional and unidimensional, three-dimensional and unidimensional. First, in engineering or in physics, we have to understand what is space and what is time. Why we require these two? For knowing the state of a particle, state of a property, because by knowing the space alone, x coordinate in the x direction, y coordinate in the y direction, z coordinate in the z direction, if it is a plane xy coordinates, if it is a three-dimensional, it is xyz coordinates, if it is one-dimensional, it is x coordinate. Then knowing the position itself is not sufficient. The time is also required. Time can be rate of change of position also, velocity also. You can have a position and a velocity from which we can find out the exact state of a particle. Now, is time three-dimensional? Is space three-dimensional? Or a unidimensional? Or a two-dimensional? Or if time is three-dimensional, two-dimensional or unidimensional? Let us try to understand from a graph. Something in unidimensional will have only the coordinate of x. Something in two-dimensional will have only plane xy plane. Something in three-dimensional, it will have all the three coordinates x, y, z. Let us say one point is there here P, it has got x, y and z. If y and z are 0, then P will be unidimensional, will have only coordinate of x on the x axis, similarly with the other axis also. Now, space means always Line means unidimensional. Please try to understand. Line is unidimensional. If a question comes like this, you can say, and plane is two-dimensional and space is always three-dimensional. So, space should have three dimensions. There are two alternatives. Space has three dimensions and time has unidimensional, and space has three-dimensional and two-dimensional. Now we have to find out which one is correct between these two. We have finalized about the space. Now we will find out about the time. You just imagine a real axis is there. It moves from minus infinity to plus infinity with 0 as origin at the center. In the space coordinate can have negative coordinates in the space and positive coordinates also. A point can be here. A point can be here. Other than positive coordinates, it can have negative coordinate. Here, x will be minus, y will be positive, z will be positive. Here, x will be positive, y will be negative, z will be positive. That means for a space coordinate, both positive and negative values are accepted. That is three-dimensional. Both positive and negative values are accepted. For time, there is no negative value. Please remember, very important conclusion we are drawing here. Time has no backward movement. Time always has a forward movement. It is a unidimensional, unidirectional. Time has unidirectional movement. That means time is always positive. Hence, it is unidimensional. Hence, answer D is correct. Out of B and D, D is correct. If time has a negative also, you can say that time is two-directional, bidirectional. Time is not a bidirectional coordinate. It's a unidirectional. Time is always unidirectional. And space is three-dimensional until and unless it is specified specifically that space is unidirectional. It can have both unidirection. A line has got the unidirection, plane has got two-dimensional, space has got three dimensions, and time has got only one dimension. That is positive, unidirectional. Now, next question. Let us think of the next. These are all basics. But people get confused in the basics only. In the examination, basics only will be questioned differently. Try to master them. Viscosity of liquids decreases with increase in temperature. For example, you take ghee. When you increase the temperature, what happens? Ghee melts. With little increase, it melts, and after melting also, as you increase the temperature, ghee starts flowing very easily on a pan, hot pan. That means its viscosity, it is losing its viscosity. What is viscosity? Viscosity is the restriction to flow. When you increase the temperature of ghee, what happens? Ghee spreads. That means restriction is lost. It is losing its restriction. It's moving fast, spreading fast. That means viscosity reduces with temperature for liquids. This is a known fact. This fact is given. Why it is? The reason behind it. Why it is? You know, all the matter in this world, whether it is a solid, whether it is a liquid or a gas, there will be intermolecular motion. With temperature increase, intermolecular motion is also affected. If intermolecular motion is increased, what happens? There will be disturbance in the flow of the liquid. And in addition to intermolecular forces, there is a cohesion. There is a cohesion also. There is intermolecular motion also. There is a cohesion. In cohesion, what happens? Cohesion is nothing but sticking of the molecules together. When temperature increases, what happens? Cohesion decreases. When temperature increases, intermolecular motion increases and also cohesion decreases. That means togetherness between the molecules decreases. Next, adhesion. Adhesion is between two surfaces. Adhesive tapes you may be knowing. That does not have any bearing on the viscosity of individual product. Hence, the option of adhesive forces is ruled out because adhesive forces require two materials. We are talking about only one single material where if temperature increases, viscosity decreases for a liquid. In that case, adhesion will not come into force. Hence, elimination in the elimination method, adhesive forces do not dominate, that is gone. And none of the above we will come to know when these two above two are wrong. Intermolecular motion. Intermolecular motion increases when temperature increases. When temperature increases, cohesion decreases. When cohesion decreases, what happens? The togetherness decreases and the molecules start spreading more. That means viscosity increases. Viscosity decreases. Viscosity decreases. Viscosity is togetherness. Restrictions to flow. Cohesion decreases means viscosity decreases. Now when the intermolecular motion also increases means viscosity decreases. Both are looking possible solutions. Both are looking possible solutions. Both are partially correct. Intermolecular motion also causes change in viscosity. Cohesive forces also causes change in the viscosity. Now, in both of them, which one dominates? I have told you in the first class itself, first MCQ, that it's not about which is correct, which is better answer. Both are looking answers almost similar. Both have similar type of effect. But something dominates more and something does not dominate. Cohesive forces dominate in case of liquids. Please make a note of it. This is the answer. Cohesive forces dominate in case of when compared to intermolecular motion. Cohesion dominates intermolecular motion. Even though both are possible reasons, cohesion forces dominate the intermolecular motion, hence answer is B. This type of questions do come in the examinations where our concepts are clear, we should never get confused by these type of questions. Now third question. Even though it's a straightforward question, I want to spend some time on this. The reason being, it's one of the most important shear stress velocity gradient curve. This shows the characteristic of the fluid. What is this curve? This is a curve like this. I will spend about some few minutes on this, and this on this du by dy. What about the why it is called as velocity gradient? I have explained in my previous videos. I will provide a link in the of the previous videos to you, and please see them. Understand what is one is called as rate of change is dx by dt. That is velocity, let us say. Gradient is defined by dy by dx. Because there is a change of space coordinate. Dy is a space coordinate, please understand. Change in space coordinate. Here also it is a space coordinate. When there is a space coordinate and time coordinate, then that is rate. When both are space coordinates, then that is called as a gradient. du is nothing but a space coordinate. Why? Du is involves L also, dl by dt, dx by dt, dy by dt, dx by dt. Rate of change of space coordinate divided by the space coordinate is gradient of this rate. Rate of rate will be, what will be rate of rate? Du by dt will be acceleration. Whereas du by dy is equal to gradient. And as per Newton's law, tau is equal to mu into du by dy. Something k we can say, some constant. Where mu is the viscosity, du by dy is the gradient, tau is the shear stress. Now, when mu is constant or k is a constant, then tau is directly proportional to du by dy. That is Newton's law. This is tau, shear stress. What is the shear stress units? Newtons per square meter in SI units, that is equal to Pascal. And du by dy units, du by dy, du is L into t to the power of minus 1 divided by L, that is t to the power of minus 1, that is second to the power of minus 1 by t per second, du by dy. This is gradient. This is shear stress. When k and mu are constants, what happens? Tau is directly proportional to du by dy. When tau, that is Newton's law. That means tau is directly proportional to du by dy. This is Newtonian fluid. For a Newtonian fluid, it goes from the origin and it's a straight line. For a Bingham plastic, it doesn't go from the origin, it is a straight line, but it has a intercept. This is positive intercept. This is Bingham plastic. Ideal Bingham plastic. This is for ideal fluid. This I have explained in my previous lectures. For further details, this is for ideal solid. Why these are called ideal fluid, ideal solid? Ideal fluid means your tau is 0. Whatever may be the value of du by dy, tau is 0, shear stress. For ideal solid, whatever may be the shear stress, the gradient is 0. These type of questions do also come in the examination. Please be ready for this type of questions. And also for Newtonian fluid, this whatever k we say that k is equal to 1. If k is less than 1, non-Newtonian pseudoplastic, k less than 1, and it is dilatant, k greater than 1. K is equal to 1, k greater than 1, k less than 1, and with some intercept. This is dilatant means k less than greater than 1. Ideal Bingham plastic means positive intercept with slope. Slope is there for the line. Then pseudoplastic means k less than 1. Here it is greater than 1. You remember this formula and you correlate your basic mathematical knowledge and get the answers. And in many examinations, I feel this is one of the topics on which a question in fluid mechanics may be there. I don't say it will be there, may be there in different twisted manners. If you understand the concept like this, any twisting will be able to answer. Best of luck to everybody. I will stop this lecture now. Best of luck to everybody. Thank you for listening to me. This is my second lecture of MCQs. If you feel my selection of MCQs and explanation is good for you and adding additional knowledge and adding value addition to your knowledge, then please share my videos and subscribe to my channel Civil Mech Maths Concepts. I am here to clear the concepts. I will try my level best to clear the concepts for the competitive examinations. Best of luck to everybody. Thank you.